Hello GATE aspirants. Welcome to part 14 of GATE Atomic and Molecular Physics series. Question number 12. Which one of the following is dimensionless constant? Permittivity of free space, permeability of free space, Bohr magneton, fine structure constant. Now fine structure constant is alpha is 1 upon 137, which is simply C by first Bohr orbit, that is V1. So this is velocity upon velocity, so it is dimensionless. So option D is correct. Next question. The atomic number of an atom is 6. What is the spectroscopic notation for its ground state? If it is 6, then its electronic configuration is 1s2, 2s2, 2p2. So this is others are completely failed. So we have to consider 2p2. So L is equal to 1, and we have to consider these 2p electrons. So for this, for first one, this will be L1 will be 1, L2 will be 1, and S1 will be half, and S2 will be half. So L will be L1 plus L2. So consider like this. So we have 2 only. So minus 1, 0, 1. So L will be minus 1 plus 1, and its mod. So L is 1. S will be 2 into half. So that is also 1. And it is less than half filled, so J will be L minus S, so that will be 0. Now spectral term is 2S plus 1 Lj, so this will be 2 plus 1, that is 3, S is 1, L is 1, so this will be P here, and J is 0, so 3P0. So option A is correct here. Next question. In a vector model of angular momentum applied to atoms, what is the minimum angle in degrees made by the orbital angular momentum vector and positive z-axis for 2p electron? Now it is 2p electron, that means L is equal to 1 and ml will be 1, 0, minus 1. These are the possible values of ml. Now cos theta is equal to angle between these, so Lz by L. So Lz by L, and that will be then ml h cut and under root L plus 1. Now possible values. L is 1, so this will be 1 plus 1 into 1 plus 1. That is 2, root 2 only. So 1 by root 2, then 0 and minus 1 by root 2. That means theta is equal to, it can be 45 degree, or if it is 0, then it will be 90 degree or 135 degree. We want minimum value. So minimum value is this. So answer is 45. And answer given in the answer key is 45 to 45. Next question, 36. It is given that electronic ground state of a diatomic molecule X2 has even parity, and the nuclear spin of X is 0. Which one of the following is the correct statement with regard to the rotational Raman spectra J? Now J is the rotational quantum number of this molecule. Now here we have to consider these options. Now lines of all J values are present. Lines have alternating intensity in the ratio 3:1. Lines of only even J values are present. Lines of only odd J values are present. So this is the question. Now, if we consider nuclear spin, if I is equal to 0, that means this nuclear wave function is symmetric. So nuclear wave function is symmetric. So this is the first thing. And in Raman spectroscopy, transition occurs when delta J is equal to plus minus 2 only. This means that this rotational quantum number can change by 2 units during a transition. Now if we consider even J values, then they correspond to symmetric rotational states, and if we consider odd J values, then they correspond to antisymmetric vibrational states. So these should be symmetric, so only for even values you will get it. So option C is correct here. Next question. Which one of the following options is the most appropriate match between the items given in column 1 and 2? First is visible. Now for visible case, we have it will be for photoelectric effect. Next is X-rays. So X-rays means that is transition between inner core transitions. So transition between core energy levels of atoms. So P, and it is used for crystal structure determination and for photoelectric effect as well. Now for X-ray, gamma rays, this is for pair production, and this is for transition between nuclear energy levels. So this is how we have to check. So for third one, gamma rays, we have Q and R. So here and here we are getting it. And for the second one, PST. So here option A is correct. And lastly, thermal neutrons. Thermal neutrons for S, that is crystal structure determination. Next, question number 54. Different spectral lines of the Balmer series, transition n to 2 with n being the principal quantum number, fall one at a time on Young's double slit apparatus. The separation between the slits is d and a screen is placed at a constant distance from the slits. What factor should d be multiplied by to maintain a constant fringe width for various lines as n takes different allowed values? Now we know this lambda, it is proportional to 1 upon 2 raised to 2 minus 1 upon n raised to 2. That means 1 by lambda is proportional to 1 by 4 minus 1 by n square. So that is n square minus 4. N square minus 4 upon 4n square. So that means this lambda is proportional to 4n square upon n square minus 4. Now fringe width beta is equal to lambda capital D by small d. That means since this d is constant, capital D, screen is placed at a constant distance, so capital D is fixed. So beta depends on lambda by d. Now lambda changes by this much amount. So d should change by in the opposite manner. That is the case. So we have this is proportional to 4n square minus 4 into 1 by d. So d should be proportional to this thing. So d has to be proportional to 4n square upon n square minus 4. So here option C is correct. So these were all the questions from GATE 2023 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.